Today we are diving into how DetaClad is shaping the future of lithium mining and recycling. Buckle up, because this is a game changer. As we transition from hydrocarbons to alternative energies, the demand for rare earth minerals skyrockets. Did you know a regular car has about 30 kilograms of essential minerals, but an electric car a whopping 200 kilograms? And lithium, it's at the heart of this revolution. The global lithium demand is expected to jump from 531 kiloton in 2030 to 1,326 kiloton in 2040. That's a 20% compound annual growth rate. So what's driving this surge? Consumer electronics and electric vehicles are leading the charge, no pun intended. But there's a challenge. Geopolitical forces influence the availability of these minerals, making recycling and reuse crucial. Recycling lithium-ion batteries reintroduces valuable raw materials into new battery manufacturing, offering a more secure and local supply. Now let's talk about production technologies: ores, brines and recycled batteries. Starting with lithium from ores, spodumene is the mineral to watch. The process involves crushing, leaching and crystallizing to produce battery-grade lithium hydroxide. Next, we have brines. Traditional methods use solar evaporation, but direct lithium extraction, DLE, is the future. It doubles lithium production and improves sustainability. Finally, recycling. With the rise of electric vehicles, the need for lithium-ion batteries is growing. Recycling these batteries recovers valuable metals, creating a unique business opportunity. But here's where DetaClad and its DetaClad technology come into play. High pH hot lithium hydroxide solutions attack steel. Nickel and titanium-clad material resist this attack, ensuring longer equipment life. The price of titanium has fallen by around 30%, thus making it more affordable as a corrosion-resistant material for highly corrosive processes. Explosion welding creates durable corrosion-resistant material for equipment essential in lithium processing. DetaClad explosion welding technique joins incompatible metals like titanium and steel, allowing equipment to benefit from the properties of multiple metals. This makes it the preferred material for manufacturing equipment in mining and recycling lithium. And the future? The Salton Sea project in California uses clad equipment throughout the facility. Using brine from geothermal electric plants, this facility could support millions of electric vehicles a year. In conclusion, transitioning from hydrocarbons to alternative energies means a greater need for rare earth minerals like lithium. The demand and usage for global rare earth metals is expected to increase, and recycling will play a crucial role for sustainable development. Solutions offered through DetaClad materials are essential in overcoming corrosion challenges and providing longer, reliable equipment life cycles. The future of lithium is bright, and DetaClad is leading the way. Thanks for tuning in.